finish up Chapter 2, we are going to talk about classifications of matter next. A pure substance, we mentioned that before, is matter that has a fixed composition and the exact same properties. Either elements or compounds can be a pure substance. An element is the simplest form of matter that has a unique set of properties. So we actually have 118 examples of these, but I just picked a couple: carbon, oxygen, and potassium. But you could look at any periodic table and that would give you a multitude of elements to choose from. So it's the simplest form of matter that we know about. A compound is a substance that contains two or more elements chemically combined in a fixed proportion. So sodium chloride is a very common compound that's table salt, and that combines sodium, the element sodium, with the element chlorine. Or ammonia is another example. We also have bleach, and there are multitudes of other compounds. We will get to those later on. This is an example of a reaction. We talked about chemical reactions a little bit in video number 1, where this is just an example. If we take sugar, and sugar is a compound, and we heat it up, so that means it's going to have a chemical reaction happening, so that's why there's the arrow. Sugar turns into carbon, which is an element, and water, which is a compound. Well, since carbon is an element, we can't break it down any further, but since water is a compound, we can break that down, and when you break it down into the elements hydrogen and oxygen. That's why it's H2O, H for hydrogen, O for oxygen. You don't have to write that example down, though. So how do we recognize a chemical change? Possible clues that we can see are the transfer of energy. The best way that we see that is by seeing a change in temperature. So that's why I have this lovely beaker with a thermometer sticking in it for us. We will see that soon. A change in color. So maybe it goes from being clear and then all of a sudden it gets bright yellow. Production of a gas. I have Alka-Seltzer tablets over here. You see the bubbles. What's happening is that's actually creating gas as the Alka-Seltzer is dissolving, and that gas is trapped in bubbles until it reaches the surface of the water. So production of a gas, you can see bubbles. Or the last one is the formation of a precipitate. Precipitate is the chemistry word for solid, specifically when it's formed as a product in a chemical reaction. So it forms a solid. If it gets chunky, if it gets cloudy, those are all signs that you formed a precipitate. So we're going to do a lab where we're going to see all of these different types of chemical changes, and these will be our clues to help us identify that a change, that is a chemical change, did occur. Antoine Lavoisier, he's back again. He helped us and was very instrumental in the law of conservation of mass. In any physical change or chemical reaction, mass is conserved, neither created nor destroyed. That whole conservation thing. So this means that the mass of the products is always equal to the mass of the reactants. Doesn't mean they're the same thing. It just means that if we had 20 grams to start, we need to have 20 grams when we're done. This is important for us today because we will learn in a little bit on another video about how scientists use this law of conservation of mass to know, okay, if I have this chemical reaction happening, I should expect this much product. So I should be able to create this much product, or maybe I don't create that much. So then I have to go back and think, okay, where did that product go? Is it maybe in a gas that I can't see or something like that? So the law of conservation of mass is very important today because it helps us in industry and in just all types of science to know that whatever we put into a chemical equation, same amount needs to come out of it. Mixtures are things that we come into contact all the time. A mixture is a physical blend of two or more components. A homogeneous mixture is the composition is uniform throughout, no matter what the sample size. So a lot of solutions, like we would see water as a homogeneous mixture. To us, to the eye, it does not look different. Alloys, like brass. If you look at a brass instrument, chances are it's just going to look like one type of metal. But if we looked at the elements that make up brass, not so much. Heterogeneous is when it's not uniform. We can tell that the composition is varying depending on the sample. So soil, river, water, milk, actually, if you let it settle, it can separate out into its different components. Concrete, Italian dressing. When we're thinking about food in heterogeneous mixtures, anything that says shake well before using is a good indicator that it's heterogeneous, meaning that the different components are settling, and so that you have it more mixtured, more mixed up, more unified, you have to shake it. Chocolate milk is a great indicator of that. So homogeneous, uniform, every sample size will be the same. Heterogeneous, not uniform, they will not be. A phase is any part of a sample with uniform composition and properties. So homogeneous mixtures have one phase because you only see one thing. But heterogeneous mixtures can have 2 phases or 3 phases or 4. It just depends on what is in that mixture. Last but not least, we can separate our mixtures based on their physical properties. One type of way is filtration. So if you're like me and need to have your morning cup of joe, you would use a filter to catch those coffee beans and the grounds so that it doesn't go into your coffee, because that just tastes gross. So that's the process that separates a solid from a liquid in a heterogeneous mixture, and we use a filter. So coffee would be your example there. Distillation separates a liquid from other components in homogeneous mixture using vapor. Our biggest example of this is distilled water. We're going to use distilled water a lot this year, and so you have to use a special machine to turn water into vapor, and then when the water is the vapor, it loses all its contaminants, and then you can condense it back down into a liquid, and that's how we get our distilled water. So that is all for chapter 2. We're going to finish up the chapter 1 to review for the test day, so we need to make sure we get all those questions answered.